All right, so this video is about function transformations, and as far as we're talking about here, we're transformations meaning where does the graph move, or how does the graph look from the original function we're given. So some of the times we're given the parent function or the mother function, whichever you're more comfortable with, and then we give you the equation. But these examples, we give you a equation and then ask you to move it or change it around a little bit. So in number 9, it says y equals 2x squared plus 3. Write an equation whose graph is shifted to the right 2 units and shifted down 7 units. Okay, the first thing I need to recognize is that this equation is a quadratic equation. And I know that because it's x squared, okay, so that's quadratic. And the graph is going to make us a parabola. Now, the most important part of a parabola, you might say, well, it's the x-intercepts. You might say it's the y-intercept. No, the most important part of a parabola is the vertex, because that's where the graph moves, correct? Everything else moves in relationship with the vertex. If the vertex moves, everything else is going to move. So we need to identify where the vertex is on this original function. Now, there's many ways to do it. You could do negative b over 2a and define the axis symmetry, then find the y part of the vertex. Or, based on the knowledge that we've gained of vertex form, there's no parentheses around x squared, meaning it's not 2x minus 2 squared, something like that. So, what that means is that the x part of the vertex is 0, and then the y part is just the constant on the back of the function, which is 3. So 0, 3 would be my vertex. Okay? Excuse me. So let me draw a little graph here. So 0, 3, 1, 2, 3, is right there. Okay? And that's the only part I need for this particular function. Okay? So I only need to know the critical point. Now and of course we started 0, 0, because almost every single function, except for a few exceptions, the critical point is at 0, 0. Okay? So we went 0, 3, so that's where my vertex is. So now I need to write an equation whose graph is shifted to the right 2 down 7. Right 2 down 7. So from my original 0, 3, I need to go to the right 2, 1, 2, so 1, 2, down 7. 1, 2, 3, 4, 5, 6, 7. So my vertex would be right there. Okay? And so my vertex moved to the right 2 down 7. And now I need to write the function for my new equation now that my vertex has moved. Okay? Now notice where we got the original vertex from, right? We got it from the equation. So that means we need to write another equation. Okay, so that 2 stays in front there. But since the vertex isn't at 0, 3 anymore, it's now at, if we do the work here, so it's at 2, negative 4. So, if the x part is positive 2, with x I actually do the opposite and write minus 2, so x minus 2. And then the y part is negative 4, so we just write negative 4 on the end. So this would be my function for a parabola that's shifted to the right 2 units and shifted down 7 units. Okay, so that's how we do number 9. Let's go ahead and take a quick look at number 10 here. Okay. So given the function, y is the absolute value of x minus 4, minus 1. Write an equation whose graph is reflected and less steep. Okay. So here's what's important here. If we look at this is called a absolute value function. It's very similar to a parabola. Let's go back up to the top here. So for this problem, the parabola looks something like this, right? Notice how it's a U shape, it has a curve to it. Absolute value is going to be very similar, but it's going to be very kind of rigid, meaning it's not going to have a curve, it's going to be very sharp. Okay? So, the vertex of this is just like a parabola. We do the opposite of x, which is 4, and negative 1. So 4, negative 1. 1, 2, 3, 4, negative 1. Okay? And then it would look something like this. Again, very similar to a parabola, but it goes very straight. It doesn't have that kind of curve that a parabola does. Okay, so that is how absolute value works. Now, it says reflected and less steep. So meaning my graph needs to be facing down here, right? So that means it's reflected. I put the dotted line there because that's like a mirror. If I were to reflect it, that's what it would be. Okay, and less steep. So what they want is something a little bit fatter or wider. So it would be like this, something like that. Okay. So first thing, let's discuss when it reflects. Now, hopefully you've seen this before. If it reflects, that means the equation has to have a negative in front, right? It's going to be negative something. And so we're going to write negative, and then it's still going to be x minus 4 minus 1. Okay, but I left a blank space there in between the negative and the absolute value bars because it's less steep. Okay, so when something is less steep, that means the slope isn't as much, or it's a very shallow shallow slope. Okay, and the bigger the number gets, the bigger the slope gets, right? So we want a number that's fairly small for our slope. So, and this equation in the original equation at the beginning, it's 1. So what's something less than 1? Let's do 1/2. That would mean the slope is less steep because it's less than 1. Okay? So in this case, 1/2. All right, so that is how we do number 10 there. And again, the most important thing I'm worried about is that you recognize if it's reflected, put a negative there. Okay? Or if the negative is there and they want you to reflect it, if you put another negative, it makes it positive. Okay, so reflection means add a negative to it. The less steep part, we'll get some more experience with that as we go on, but just want to make sure you're aware. Okay, so for number 11, let's take a look there. Y equals 2/3 x minus 2. Write an equation whose graph is shifted to the right 5 units and reflected. Okay, so to the right 2 units. Now notice how there's nothing with x, right? There's no parentheses around it. Well, you'll say, wait, what about that minus 2? Well, that's not attached to the x because it's minus 2. Remember, if there's something with x, there'll usually be parentheses or it's all up in the exponent, okay? So it says to the right 5, so I need to write y equals 2/3 x. Now normally we think to the right 5 means positive 5, but if we want to the right 5, we do the opposite, so we need to write x minus 5 minus 2. Okay. And then it says, and reflect it. And if it's already positive 2/3 to reflect it, we just put a negative in front, so it's negative 2/3. Okay, so again, the key things here is that you know where the critical point is, all right, and that you know how to write the shifts properly. Drawing pictures is really good. If you could draw some pictures, that'd be really important. Oh, I forgot to do it for number 11. Okay, so 2x to the third minus 2. So if I were to draw a picture of that, it's a line. So my y-intercept is negative 2. And this would go up 2 over 3. Up 2 over 3. So my line would look something like this. Okay. All right. And so it says it shifted to the right 5 units. So what I'm going to do with that is move this over 5 units. So 1, 2, 3, 4, 5. Okay. But it's the same exact line, and it's going to be reflected, meaning it's actually going to look like this. Something like this. But the easiest thing to remember is that if there's nothing with x, just go ahead and put that 5 with x and put it in parentheses, and that will take care of it. And reflections, make sure you add the negative.